Hello, and thank you. Thank you for the introduction, and hello to everyone who's joined today. I want to thank everyone for taking some time to check out both GeoOil and GHGSat here. And thanks for the opportunity to present at your booth. So with that, I guess I'll jump right in. My apologies, as I think I heard. I don't speak any Spanish, unfortunately, but Oscar can certainly help us out as we go. And of course, if anyone has any questions or comments along the way, it'd be much more engaging if we have a conversation. But I'm also happy to just provide an overview of some of what we're doing at GHGSat. And so for today's presentation, I thought I would keep it pretty high level about what we're doing, but just to give everyone a sense of what GHGSat is up to, we are pioneering a different way to do the detection of emissions remotely. And today we are very focused on the detection of methane, and we're doing this in a bunch of different ways. We do operate our own satellites, and I'll talk about those. We also have some unique analytics capabilities, as well as an aircraft sensor that I'll touch on briefly. Today, we are entirely focused on methane emissions. However, in the future, no doubt we will expand our capabilities to carbon dioxide and other gases. As well, I'll try and keep an eye on the chat if anyone has any questions there as well. But maybe before we dig in to the details, just a quick note about why we might want to measure methane emissions. Of course, everyone has their own specific needs, but we like to highlight a few. Obviously, economics is a key one if natural gas is a product you're trying to sell. But more and more, it's these items further to the right. In particular, the idea of disclosures, whether it's investors or acquisitions, everyone is looking to better understand what exactly is going on from an emissions perspective at all sorts of companies around the world. And we are working with companies to do exactly that. Further to that, though, of course, there's health and safety concerns, and then ultimately there's regulation. And so depending on where you're operating, there's different levels of regulation, but increasingly we're seeing the effects of carbon pricing and taxes, and we're seeing that leak monitoring and measurement plays a key role in validating supply chains. In particular, right now in Europe is one area that's of keen interest in terms of providing, a more sustainably sourced energy and responsibly sourced energy, and making their determinations about where they source their fuels, in part at least, on meeting certain minimums. And so we can help with those types of challenges for all sorts of industries. Now, going another layer deeper here, why do it remotely is maybe a slightly different question. And there's a few advantages here, but in our case, the keys are the economies of scale. So owning and operating satellites that are capable of measuring methane allows us to look anywhere in the world when we need to. It's also very easy to deploy. So at GHGSat, strictly speaking, you could provide us with a set of coordinates and we could go observe that location for emissions. In terms of performance, GHGSat being a capability that provides direct measurement is different than the bottom-up estimates that are often used across a variety of industries, and providing sort of a top-down perspective allows you to really understand what the real measurable changes are or improvements are in your operations, rather than just making estimates based on numbers. Lastly, this also provides a level of consistency and transparency across industries and around the globe, which really allows those that are, wanting to make a statement about meeting their commitments going forward, allows them to, make that public in whatever way they feel most comfortable on their own terms. So where this all leads to is from our perspective, is what's important here is to find the big emissions fast. And so if you can find the largest emissions quickly, you can have the best impact on your bottom line, you can have the greatest impact on the environment from a sustainability perspective. And so those are sort of the two key drivers in how GHGSat approaches emissions detection and hopefully support of emissions reduction. There's of course many papers on what the distribution of emissions is. And the reason why I put this up here is because the good news about this type of approach is it's relatively easy to have a large impact quickly. And so what this graph shows, and many other studies in addition to what I've listed here, repeatedly show that a small fraction of all of the emissions are coming from, or a large fraction of all of the emissions are coming from a very small fraction of the locations. And so that makes it much easier to find because those emissions are generally speaking larger. So one way to do this, and the way that GHGSat is pursuing, is the idea of tiered monitoring. And this is not a new concept for any of you, I'm sure. But at GHGSat, we're kind of focused on the top three tiers, being sort of an analytics, satellite, and aircraft-based approaches. In complement to that, there are ground-based drone capabilities, optical gas imaging, fence line systems, all of which have specific advantages and disadvantages. And the way we see this playing out is that we want to start with the lowest cost, greatest impact approach, and then increase the resolution as well as source detection and identification where needed, when needed, as well as the sensitivity, because as these things improve, generally speaking, the costs also improve or increase. So for today's conversations, I'm going to talk strictly about the analytics satellites, and I'll touch briefly on the aircraft. But I thought that this would be, at least help frame our discussion. This is a one way to think about these capabilities. So diving into the analytics side of things here, I'll first put up this, and hopefully the video plays through okay for everyone. But one of the things we're doing at GHGSat in terms of analytics is we are ingesting large amounts of public and private data, and we are generating, in this case, a global methane map. Now, this is available, as I put up there on the link you see, pulse.ghgsat.com if you want to check it out. But the reason I put this up here is really to just, this is intended to really start the conversation and show some of the capability that we have. Now, this is a high level time series with monthly averages over the course of about 6 months. And what it really points to is analytics in some ways can provide us, a historical perspective to help understand what's going on today. And we see significant interest from oil and gas operators as well as regulators in this type of an approach of looking at sort of large areas on a frequent basis with relatively low cost. And so when we go down, to the next layer here, what's on the right-hand side is actually a concentration map. So this is methane concentrations in the atmosphere. As you can see, we've put sort of the Permian Basin in Texas as a focal point there. But the idea here is that we're generating a unique 2-kilometer pixel resolution map, and we're doing that with GHGSat satellite data, TRPOMI satellite data, and other satellite data sources that are all contributing to this global model. Now, the concentrations on their own are interesting, and there's some information available at the operator level that can be derived from this. You can see things like where there may be unexpectedly high concentrations, and those we represent in the form of, say, a hotspot. So we can trend pixels at sort of this 2-kilometer resolution over time, and as a monitoring capability or an indicator that might otherwise show something negative happening or something unexpected happening. And so on its own, the concentration maps may not tell you the whole story, but they can start to give you some of the pieces, of what's going on. And so this is, many of our products are available through the Esri platform going forward. But not only can analytics sort of look in historically, they can also start to look forward. And so if we zoom in on this example here, we have sort of similarly the concentration map. And like I said, we also have the hotspots. Now what we've added here is the idea of facilities. And so these black dots that you see on the right-hand image, those are specific facilities anonymized, of course, but it's facilities from an operator. And what we're doing around those facilities is we're making predictions. And the reason why predictions are important is because they allow us to sort of look forward from the information we have to determine not only what the risk of an emission is, which we represent in our case, with the color code going from sort of green to red, but also a confidence in those risk predictions. And so we can say, how confident are we in that type of, in that prediction that's being made? And so these are all products that we currently deliver. But what it's enabling, like I said, at both the operator level and the regulatory level, is the efficient use of resources. That's the number one application or interest we have today. There are, of course, others, leak detection and that sort of thing. But at a high level, just this alone can, inform the use of some of those other technologies I had up earlier. Things like whether you want to deploy drones or individuals on the ground or aircraft sensors. This type of information gives you a high-level overview, and you can almost think of it as, an insurance coverage for any large emissions, hopefully being detected early on. And by detecting those large emissions early and preventing them from going on for an extended period of time, you'll have a much greater impact than simply, finding many small leaks, which also requires a lot more effort. But if we want to go down, excuse me, one more level from the analytics, we can talk about the satellites that are available today and the different satellite capabilities that are planned. The table on the right is a good summary. It's not my own. I borrowed it, but it does provide kind of a nice summary, I think, to just give a sense of what's out there in terms of satellite capabilities. Now you'll notice when you get a chance to look through this here that there's a lot of variability, not only in the detection thresholds and pixel sizes, in terms of what you can see, but also a key one being the availability as described by the launch column. So you'll notice that many of those are in the future. The other thing I will say is many of these are complementary to what we're already doing on the analytics level. So anyone who is making data publicly available is adding to our capabilities to improve our predictions and improve the concentration maps and hotspots and all of those things. So as we go forward, we are keeping that in mind as part of our vision for the product offerings that we have. And then the key point here, perhaps from our perspective, is that you have sort of two different coverage processes. One being sort of a global coverage, which is sort of a frequent, very high level, almost climate level type of information. And then you have targeted. And so GHGSat falls definitely into this sort of targeted category. And the reason why that's important is because we're looking at specific facilities. And the reason we can do that is because we have the resolution to see those facilities. Having pixels that are, sub 30 meters allows us to identify specific sources of emissions versus other available capabilities today that give you good regional information on a regular basis, but can't necessarily isolate the source. And so where GHGSat is really able to show its capabilities best for our clients is identifying specific emission sources. And I'll talk a little bit more about how GHGSat does that. So here's a quick example on the right. This was a oil and gas facility that we have imaged some time ago with our demonstration satellite. What you're looking at is actually methane enhancement. And so when I say enhancement, what that means is this is the methane present in the image that we acquired that exceeds the natural background level. And so there is always methane in the atmosphere. And what we do is with our satellite, we target a particular area. And when we make our observation of that area for each pixel, we determine the methane concentration. And then we take that measurement for each pixel. And the field of view that we're capturing is roughly about 12 by 12 kilometers. And so for each pixel in that 12 by 12 kilometers, we determine what the methane concentration is. We then determine, loosely speaking, what the average is from all of those pixels, and then we subtract that. And so what that does is it allows us to compensate for local differences, and you saw those differences in the map that I showed earlier of what methane concentrations might be around the globe. And it allows us to really show what's there in excess of the background level. Now, you'll also notice that the units of measure here are parts per billion. And while that is obviously extremely sensitive, the way to think of this information is that these concentrations are actually averaged over the entire atmospheric column that is above each pixel. And so because we're averaging what we see over roughly about a 500-kilometer vertical column between the satellite and the surface of the Earth, we need to have a very high sensitivity in order to make these types of measurements. And that's where our patented instrument and approach comes into play, is that we can do this at the spatial resolution to the point where we can get people to facilities that have or have experienced emissions-related issues. Further to that, of course, we can do quantification based on these observations, and we currently have the highest resolution and lowest detection threshold available from space for methane emissions. Another quick example, and I bring this up because this is one of the first images from our commercial service satellite named Hugo, which we launched in September of this year. Our prior satellite, GHGSat D, also named IRIS, we put up in 2016, proved out the concept and made many of the examples that I've shown you already. But with this new satellite, we're seeing a significantly improved detection capability. And we're building on that further, launching another satellite this year, before the end of this year in December, and then 3 more satellites in 2021, followed by 5 more satellites in 2022. And while that probably seems like a lot of satellites, our satellites are roughly the size of a microwave, and they weigh about 15 kilograms. So they're very small compared to many satellites that are in use for this type of thing today. And the reason why we're doing that is because, as I mentioned earlier, we capture a 12 by 12 kilometer area, roughly speaking, per image. But with a single satellite, obviously, it would be impractical to try and measure the surface of the Earth with a single satellite. And so adding these satellites decreases what we call the revisit time, or the time it takes to get back to a particular location on the surface of the Earth to measure it again. And so come 2022, we will essentially have daily global coverage. Today, with a single satellite operating Hugo, we have coverage once every 2 weeks. So we're expecting a significant ramp here with much of this funded innovation. I also mentioned that we do have aircraft, and so I'll just touch on this very quickly here, but we've taken the satellite-based sensor and installed it in the aircraft along with a high-resolution black and white camera. And we're using this kind of capability in a variety of circumstances. Again, it's a similar data product in terms of methane. Again, going sort of down this value chain and through these tiers, the costs are going up, but the detection capabilities are also improving. And so one way that we're combining these things together is using analytics, follow-up from satellite, and say some sort of biannual or that type of survey service provided with the aircraft instrument. Not to be missed as well, as part of the airborne uniqueness, is that we are able to provide background imagery, which does present additional value in addition to the emissions information. It can give you information about what's happening on a particular site, as well as may even show you things that are happening just off-site that you wouldn't otherwise see. And then similar to the satellite side of things, we are adding additional airborne instrument capabilities. In the case of our aircraft instrument, we are less than a meter per pixel. And we started work in 2019 with the aircraft sensor very late that year, and we're building 2 more of those, which will become available in 2021. Primary interests for the airborne assets, like I said, are mixed, but often it's linear assets such as pipelines or that type of asset, as well as looking in basins that may be densely populated, where we can look to distribute information across maybe one or more potential clients. I'll just give a couple quick examples of combining tiers here to sort of round things out. And I'll start with this one, which was kind of interesting because this was the early days of our analytics. And as I mentioned, you know, we don't take very large pictures when you compare it to the surface of the Earth with the GHGSat satellites. And so in some ways, the analytics that we've developed were actually built out of necessity to target our satellites. And so this shows some of our early work where we were taking tropomi data. Tropomi is one of the satellites I showed earlier. We're taking that data and using it along with weather and other information, whereby what you see with the red squares there were areas that had elevated methane concentrations, and with some wind data, as well as our own algorithms that we're developing and have developed, we're able to backtrack where we thought the emissions were originating from, as designated by the pin that you see, the yellow pin. And so what we were able to do then was target our satellite on that particular location. And sure enough, you know, we were able to identify an emission happening there. So this was one of the very first times we had done this. Of course, we've increased the polish on this capability going forward. But I just thought I would show a little bit of the progression we're having already on the analytics side. So fast forward to a little closer to today. Again, looking at sort of the Texas Permian Basin area there. This article is also available on the European Space Agency website for anyone interested. But what this shows here is that if we use some concentration information and combine it with our own proprietary analytics algorithms, we can use that to intelligently target satellites to isolate and locate where emissions are coming from. This is obviously extremely powerful for operators in the field. And like I say, in terms of deployment, with high resolution satellite imagery from GHGSat, you can effectively identify, you know, down to the pad level where assets need to go to make repairs. The other thing I'll point out just briefly here is you may notice on the left-hand panels there that are showing atmospheric methane concentrations that we didn't necessarily image the area that was of the highest methane concentration. The algorithms are able to incorporate other data sources such as production, facility, climatic data, flaring. So we're pulling in a whole bunch of different sources, and what that allows us to do is make better, essentially guesses, better estimates of where emissions are coming from, not just looking at on its own the concentration information. And so you can see that the area we targeted actually isn't in the area with the highest concentrations. And that's further complicated, of course, because the concentrations are changing around the surface of the Earth. So I will finish by just saying that oil and gas is not the only sector we're working in, but what is happening is the world is changing in terms of how methane emissions are observed, how they are captured, and you know, we're finding ourselves you know, engaging with a variety of industrial sectors, looking to help them understand and ultimately reduce their emissions profitably, or at least at a minimum cost. So I'll leave it there. And again, thank you for your time, and hopefully there's lots of interesting questions. For anyone interested, this was the launch of our satellite from French Guiana at night, September of this year. So thank you.